Today we are going to discuss relative velocity problems. In that, prominently you have the rain problem there. So these type of questions and the problems we'll discuss in today's discussion. So let's see, first of all, what is rain problem? All these are based on the relative velocity problems. It is just the relative velocity of one body with respect to another body which we are using. So suppose we take, first of all, what do you mean by the relative velocity of the two bodies there, especially in the two dimension if you consider. Suppose you have a body A and another body is B. Body A is moving with velocity VA and B is moving with velocity VB. So if you want to find relative velocity of A with respect to B, then we represent it as your VAB. And this is given by velocity difference, that is velocity of A minus velocity of B. Similarly, relative velocity of B with respect to A, if you want to find, it is the velocity VBA it will be written, it is the velocity of B minus velocity of A. And again, just you see, it is the vector difference. So it is the vector difference principles we'll be using there. They are a vector sum will take, that means it will be a vector sum of first vector and negative of the second vector. That is given by the vector difference. So all these problems of the relative velocity are basically your vector difference problem there. So let's take one type of problem there that is called as the rain problem. For rain problems, let's just try to imagine that it is raining and you are standing at a particular place and you are holding an umbrella. If you are using your umbrella to protect yourself from the rain, then how you hold the umbrella? You are holding it straight so that you can protect yourself from the rain. And we are assuming that there is no wind. That means the rain is falling vertically. If you start walking, in that case, you need to tilt the umbrella. If you are just walking very slowly there, in that case, you may not be able to notice. But if you start moving fast, or if you start running, then you need to tilt your umbrella. In which direction we tilt the umbrella? We tilt it in the forward direction. That is the direction in which we are moving or running. Why it is so? Because the rain appears to fall in that particular direction. That means basically it will appear to fall vertically there at some angle there with the vertical. And it will be in the direction from front. So here, or if you are not using umbrella, in that case the rain will be falling on your face. So you can notice that if you are standing at a place, if you are stationary, then the rain is hitting your head, not much on your face. But if you start walking or running, then the rain will appear to strike more on your face. Is it that the rain has changed its direction? No, because if you stop, in that case again you find that the rain is falling on your head, not so strongly on your face. So it is just that rain appears to fall in that direction. And that is why we say that it is a question or problem of relative velocity, because it appears as if it is falling with that particular velocity to a particular object. To make it more clear, let's assume that this is the direction of velocity of rain. That means the rain is falling vertically. We are assuming there is no wind there at that moment. And any person is there who is walking horizontally with the speed, suppose v. So he is moving in this direction. Now, if you want to find relative velocity of rain with respect to man, so if I take suppose VRM, which is relative velocity of rain with respect to man. So what will be? This will be by definition VR minus VM. This is your VRM. Now, so it is the vector difference. How we find vector difference? We take the first vector as it is and we represent second vector with its negative vector, because this is basically VR plus minus VM. So we'll represent the velocity of man in opposite direction so as to get the negative velocity. So this is now your minus V. Now it is the sum of these two. So we'll take the resultant of VR and VM. This is the resultant. And now this is representing your VRM. VRM is your VR vector plus minus VM vector. So this is the direction of the relative velocity of rain with respect to man. That means it appears to fall at this particular angle theta. So the rain will appear to fall in this direction. So if the person is holding an umbrella, he will definitely keep the umbrella in perpendicular direction to its fall there. So that means his orientation for the umbrella will be something like this. So this will give you the angle at which he needs to tilt his umbrella to protect himself from the rain. So in that case, as the rain will be falling in this direction, you need to tilt the umbrella in this direction. Now, what is this particular VRM value there? If it is such, of course, it is the vector sum there. And here in this particular case, as it is in perpendicular direction, these two, so it will be simply given as your square root of VR square plus VM square. And if you want to find what is this tan theta, that is at what angle he needs to tilt the umbrella. So in that case, how much it will be? This will be equals to your VM by VR, or theta will be equals to tan inverse VM by VR. So this will give you the angle at which he needs to tilt the umbrella. This will give you the relative velocity of rain with respect to man in magnitude. So here you can see rain is actually falling with the speed VR. And here it will appear as if it is falling with the speed, which is VR square plus VM square square. So obviously it will be more there. That is why if you start moving or running, then the rain will appear to strike with greater velocity. So it will appear to strike more on your face with greater force there. Similarly, suppose if you take this particular case, theta is giving you the angle at which you have to tilt the umbrella. If you start running, then we know that VM will be increased now with respect to the case when it is a stationary or you are stationary. So you need to tilt it. If you increase your speed, in that case, what will happen? If you are increasing this VM, then theta will increase. That means if you start running with greater and greater speed, you need to tilt the umbrella with greater and greater angle with the vertical. So that will be the case there when you are taking this speed and you are increasing your speed regularly and gradually also. That is why you might have noticed if someone is running and he is holding the umbrella, he is tilting the umbrella at particular angle. But if suppose someone else is there who is there on a bicycle and he is also holding an umbrella in one of his hand and he is moving on the bicycle, definitely he will also move with higher speed. That means he will try to increase his speed there. So with respect to the running man, that if we assume that the speed of the cyclist is more there, then you will notice that the cyclist needs to tilt the umbrella with more angle there with respect to the person who is running there with a speed definitely which is less than the cyclist's speed. So this is exactly what you can show here, that if it is more, in that case you need to tilt with greater and greater angle there. Now, another thing we can take, we are using umbrella to protect ourselves from the sun rays also. If suppose it is noon, so at noon, if I assume that we are standing at a place and sun is just overhead, so in that case, we hold the umbrella straight. Just the case, if the rain is falling vertically, we are holding the umbrella straight to protect ourselves from the rain. Similarly, at noon, when the sun is overhead, we are holding the umbrella straight there. But when we start moving or running to protect ourselves from the sun rays, do we need to tilt the umbrella? We don't need to tilt. Why is it so? Because it is also a similar case there with respect to the rain we are taking. In case of rain, if it is falling vertically and we start running, we need to tilt the umbrella at some angle. But in case of sun rays, we never need to tilt that. The reason is, you can see here, this was basically Vm by Vr, that is the tan inverse of that quantity is theta. For rain, it is your Vr. For light, it will be the speed of light here in the denominator. And you know that the speed of light is very large as compared to the person's speed. In that case, this fraction will be negligibly small. And if it is negligibly small, theta value will be almost 0. That is why we don't need to tilt the umbrella if we start running and we want to protect ourselves from the sun rays. But in case of rain, as the speed will be the moderate, where you cannot neglect the person's speed there, in that case, definitely we need to tilt the umbrella. For solving rain problems, I will suggest that you better use vector method, because there are other methods also, that is the geometrical method, where they represent it in the geometrical diagrams there and using the properties of the triangle there and geometry, they can find out the required quantity. But if you are using vector method, in that case, it may appear that initially when you are doing it for the first time, it may appear that it is slightly lengthy in respect to the shortcut method which you are using by drawing the diagrams. But remember, if suppose the problem which is given is simple one, there you can easily draw the diagram and find the answer. But if the problem is complex, then you will have to think a lot to draw its diagram. Once you draw the diagram, then only you will be able to solve that one. But if you are using vector method, you have to do in a particular systematic order, whether the problem is simple or a complex one. So for all types of such problems, you can use vector methods, and it will be a normal traditional method of solving it. So you can easily solve any type of problems there on rate problems easily by using vector method. Let's try that one, how we are using that one to a particular problem. Suppose it is given that to a man walking at 4 km/h, rain appears to fall vertically. When he doubles his speed, it appears to fall at an angle 45 degrees with the vertical from the front. What is the velocity of rain? So it is given that the rain is falling there and the man is walking there at particular speed. To the walking man, it appears to fall vertically. So obviously it must be not falling vertically there. It must be falling at some angle. Because if it is falling at some angle, like this, suppose it is falling, and if the man is, this is the direction of velocity of rain, this is the direction of the velocity of man. If you take now the opposite one, that means the negative velocity of man, so that the resultant of the two may be somewhere in this direction, which is vertical. So this is your relative velocity of rain with respect to man direction. And it is given that it appears to fall vertically. So by drawing the diagram and attempting with the given data there, you can solve it. But let's try it by vector method. What we do, we suppose assume that horizontal direction is x-axis. and vertical is y-axis. Okay. So here, velocity of man, we can represent it as your 4i cap. If we take let horizontal and vertical directions be taken as x and y axis respectively. So I can write velocity of man as your 4i. Velocity of rain, this we do not know. We have to find this. So let it be represented as ai plus bj. Remember, our aim is to get the velocity of rain. And if it is written as ai plus bj, if I know the value of a and b, I can directly say what is the magnitude, which is the square root of a square plus b square. What is its direction? So tan theta will be your y component by x component, that is your b by a. So from that we can find out what angle it is striking. But if we do not know, let's start with that it is your ai plus bj. Now, relative velocity of rain with respect to man, this will be given as your Vr minus Vm. So this is your ai plus bj minus 4i, and that will be equals to a minus 4i plus bj. This is your relative velocity of rain with respect to man. Suppose I call this as equation number 1. And it is given that rain appears to fall vertically. That means if the rain is falling vertically, like here, in that case, with respect to the direction of man, how much angle it is making? Because the man was moving in this direction. Vrm is in this direction. So in this case, it is this particular angle, that is tan 270 degree. This is your y component by x component. So it is b by a minus 4. Tan 270 is infinity. So it is your 1 by 0, that is b by a minus 4. And that implies that a minus 4 is 0 or a is equals to 4. So that means now for velocity of rain, you at least know its x component. So velocity of rain, we can write it as your 4i, but still b is unknown. New velocity of man, because it is given he is doubling his speed. Okay, he doubles his speed. So that means new velocity of man, suppose I represent it as your Vm dash. So this will be your now a type. Now this time, again, if I take relative velocity of rain with respect to man, that means it is now the new velocity, new relative velocity. So this will be your 4i plus bj minus 8i. This will be your minus 4i plus bj. So this is the expression for relative velocity of rain with respect to man, that is the new velocity. And this time it is said that it appears to fall at an angle 45 degree with the vertical from the front. That means if this is the direction there, vertical one, it appears to fall from front. That means this is the direction from front. And this is at an angle 45 degree with the vertical. That means this particular angle, if I take, it will be your 270 minus 45 degree. So that means now this time it is your tan 270 minus 45. That is equals to b by minus 4. And this one, if you consider, it is lying in which quadrant? It is lying in the third quadrant. And in third quadrant, if you consider, in that case, tan is positive. Tan and cot is positive. And this will be equals to this as a cot 45 degree. That is your b by minus 4. Or this is your 1. So that is your b by minus 4. And that is b is equals to minus 4. So that means now we have got the velocity of rain I, and this was your minus 4g. So this is the velocity of rain. Now, if you have to tell what is its magnitude, what is its direction, in that case, we can easily find it. So velocity of rain, we have got it as 4I minus 4j. That means value of A was your 4, we have obtained as minus 4. So if it is asked what is its speed or magnitude, it is your 4 square plus 4 square, and that is your 4 root 2. At what angle it is falling? So it will be your tan theta. That is equals to y component by x component. It is minus 4 by plus 4. That is your minus 1. And for what value of theta we get it as minus 1? This is possible when theta is either 135 degree or 315 degree. Because the tan theta is minus 1, this is possible at two different angles there, 135 and 350. Which is the correct one? Here, if you see, if this is the horizontal, this was your vertical, 135 degree angle orientation will be something like this. And 135 degree will have the orientation like this. Or 315 will have orientation like this. It is rain. Obviously, this cannot be the direction of the rain. It will be like the water fountain you are getting. So this is the rain. So obviously, this will not be the correct one. And 315 is the correct one. So that means this angle is not the correct one. This is the angle. So theta will be equals to 315 degrees. So that will give you the direction of the rain. So that means that also we have shown here. If it is falling in this direction there, in that case only you can get the resultant relative velocity of rain with respect to man falling vertically if it is moving with a particular speed. If it is in the second quadrant, it is never possible. Second thing, what you can get it from this also, here if I take velocity of rain, it is your 4I minus 4j. That means it is your x component positive and y component is negative. In which quadrant we get x coordinate positive and y negative? That is only in the fourth quadrant. So in the fourth quadrant only, that means this quadrant, you have x positive, y negative. Here, first quadrant, all positive. Here it is your negative and positive. Here both are negative. And here it is your positive and negative. So it is in the fourth quadrant. So obviously this angle should also lie in the fourth quadrant. So that is why it is 315 as the correct answer. So this way you can solve the numericals on a rain problem there. Only thing is just remember, here when you have taken the rain and there is no wind, only person is moving, then it is the relative velocity of rain with respect to man. But if the wind is also there, in that case, there will be resultant velocity of rain, which will be the velocity of rain plus velocity of wind. And then that resultant velocity of rain, you will take for the relative velocity for man. So basically, in such problems there, if you consider, it is your velocity of rain plus velocity of wind as the resultant one. And then it is the velocity of man which will be subtracted. This will give you new relative velocity of rain with respect to man. That means especially in presence of wind which we are taking. Effect of wind on rain speed will give you resultant velocity. But the motion of the man, for that, rain speed will be a relative velocity problem. Let's take another question. A man is standing on a road, has to hold his umbrella at 30 degrees with vertical to keep the rain away, he throws the umbrella and starts running at 10 km per hour. He finds that the raindrops are hitting his head vertically. Find the speed of the raindrops with respect to first part, the road, and second, the moving man. For solving this type of problem, again we'll assume that let velocity of rain is AI plus BG. Here we are taking horizontal direction as x-axis and vertical direction as y-axis. Now suppose if it is mentioned there that he needs to hold the umbrella at 30 degree with the vertical and he is standing. That means this is the actual direction in which the rain is falling. So for that, if you consider that this particular will be the direction in which the rain is falling, and this is falling at an angle 30 degree with the vertical. If this is your x-axis, this is your y-axis there. This is origin, suppose. So now, if we have represented the velocity of rain in this direction, so if it is making an angle 30 degree with the vertical, so with x-axis, if you consider how much angle it will be making, this will make an angle of tan 270 plus 30 degree. This will be the entire angle if it is measured in the anti-clockwise direction, and that is equals to y component by x component. So this is your tan 270 plus 30, that is equals to minus cot 30. So this is your b by a, and this is your minus root 3 b by a, and that gives you value of b as minus root 3 a. This is your first part. Now, if you consider velocity of rain with respect to man when he is running, he is running at a speed of 10 km per hour. So in that case, velocity of rain minus velocity of man, it will be there, which is your 10I sub, which is equal to AI plus BJ minus 10I, because velocity of man, it is given as it is running at 10 km per hour. So this is your A minus 10I cap plus BJ. Now it is given that to the running man, it appears that the raindrops are hitting his head vertically. So that means to the man, it appears as if the rain is falling in this direction. So in that case, this particular angle will be equals to 270 degree there. So now tan 270 degree, this is your b by a minus 10. Tan 270 will be your infinity, that means it is your 1 by 0. So this is your b by a minus 10. Or a minus 10 is 0, or a is equals to 10. So we got the value of a. And once we got the value of a, then b will be equals to minus root 3a. So this is your minus 10 root 3. Therefore, velocity of rain will be 10I minus 10 root 3g. Now, in the first part, so this is the expression. In the first part, it is asked what is its speed with respect to the road. That means this is basically the actual speed with which rain is falling with respect to ground or with respect to road. So for first part, velocity of rain with respect to the road, you can say this will be equals to velocity of rain minus velocity of road, which is 10I minus 10 root 3j minus 0, because this is 0. So in that case, it is your 10I minus 10 root 3j. And if you want its magnitude, in that case, VR with road in magnitude. This will be equals to a square root of 10 square plus 10 root 3 whole square. And that is equals to 100 plus 300. And that is equals to 20 kilometer per hour. Now, second part is with respect to the moving man. So that means now we want in the second part velocity of rain with respect to man. So it is your 10I minus 10 root 3j minus 10I, because the moving man's speed was your 10 kilometer per hour. So this is your minus 10 root 3j. And if you take its magnitude, it is your 10 root 3 kilometer per hour. So this is how you can get the expression for the speed of the rain with respect to road, the speed of the rain with respect to the moving man.